going to be a lot of content in this slide eventually, but the way I'll go is I'll sort of display module by module in this animation. I'll talk about every module as its responsibility, and then eventually we will look at the write path and read path guided by some arrows in the animation. So first up is historical. Historical is where your data, let's say queryable data, stays. So when you ingest some data via some path that we will see, it will end up going to historicals, and the Druid segments containing this data, the immutable segments, they will be distributed mostly evenly around all these historical nodes. And when you query most of the data for the query, at least the historical data for the query, will come from these historical nodes. Then there is middle manager. Middle manager is another bunch of workers which is tasked with executing tasks for ingestion. And you can scale that horizontally like you see in the diagram. Coordinator coordinates between historicals, deciding, which segment should go where, how do I balance stuff like that, how do I add a segment, drop a segment, things like that. Overlord manages sort of to distribute tasks between middle manager workers. And these middle manager workers basically have something called peons. So if the middle manager has, let's say, 10 tasks, it will sort of, for every task, it will try to spin up a JVM process. That JVM process will execute that ingestion task. In sort of, if you look at the latest Druid code base, it's called indexer, but I think it's still a little bit experimental. So we are really excited that, from process-based, this is going to move to thread-based task execution. So we are having a look at that, but that is something that is quite interesting. Then there are some external dependencies. You see Zookeeper. Then you see metadata storage, where we use Postgres in our case, but you can use other SQL databases. Then there is deep storage, where we use S3. You could use other object store or SDFS, and even Nutanix object store. Broker is where your external clients will end up asking to execute queries. You can put routers, and it's recommended if you have a production setup that is sort of supposed to take care of a lot of data ingestion and stuff. So router is basically optional, and it will help you route queries to the brokers, overlord, and coordinator. Okay, so we come to the sort of write and read path. First, with write path, you can sort of have streaming ingestion, or you can have batch ingestion. So the kind of workloads which we are talking about here, those clusters for us are using batch ingestion. And for the streaming ingestion, I think the third and fourth talk, they use streaming ingestion, so you'll get more insights there. But very quickly, if you look at the write path, you ask the router to route the writes. It will send it to overlord, which will take the ingestion task. It will ask middle manager to execute that task, and middle manager will eventually spin up a peon process, which will execute that task, and sort of the data will eventually be put by these peons on deep storage. And eventually, that new arrow is dotted because deep storage to historical will not sort of go directly. It will go via coordinator. But just to sort of keep the picture clear, I sort of put a dotted line, conditions apply and stuff like that. Very quickly, on the read path, you again ask the router to execute a query. It tells the broker to execute the query. If you don't have routers, this will go directly to the broker. Broker will talk to historicals. The name is so good, no? Historical data. Middle managers have some of the latest real-time data, which are not there on historical yet. This will eventually land up there. So broker will get data from middle manager as well as historical, sort of combine them up and serve what you expected from the query.